write down what I'm given, and I'm going to build this little shell here. All right, first I want to deal with my unit. Okay, ML's got to go on the bottom, L's got to go on the top. Why? Because ML has to cancel. Now, what else do we have going on? Well, we're going to the table, and we're going to look under milli. When I see milli, I see 1 times 10 to the minus 3. Of course, by default, a 1 will go there. All right. I mean, you know, a lot of people, it's counterintuitive. They think, well, 1,000 milliliters is a liter, and that is true. But, you know, again, I am working this because your book does this. That way, when you get home, you have consistent notes. Here, there's a liter on the bottom, and what goes on the top? A deciliter. All right. So, 1 goes with deci. All right. And what is the number that goes with deci? 1 times 10 to the what? To the 1? Was it 1 or negative 1? Negative 1. All right. So, 37 times 1 times 10 to the minus 3 divided by 1 times 10 to the minus 1. All right, that is 0.37. Is that what you're getting? Deciliters? Okay. Kind of a weird unit. However, if you're in the healthcare field and you look at some of the units of a lab report, deciliter is certainly shows up a lot of times. All right. Okay, are we good with two-steppers? Yeah, maybe. Okay, so let me tell you what you're going to need to know how to do. The first thing that you're going to need to know from memory, okay, is the table on page 23. In other words, you will have to go from the metric to the metric by memory. Because, see, that's what the scientific community uses. Well, that's what most of the world uses, all right? The United States doesn't. But every other place uses this metric system. And you will need to know that from memory and so forth. But let me tell you what you will not need to know from memory, but you will need to know how to do it. How to do it given the table. And that is if you go from metric to standard, and if you go from standard to metric. All right, in other words, I do not require you to know how many grams are in a pound. I don't require you to know how many meters are in a mile or something along these lines. If you need something like that, it'll be given to you. Now, it won't be next to the problem, say, please use this number to work this problem. It'll be on a big table in the back, all right? And we've not did any of those yet, by the way. I'm just telling you what to go ahead and prepare for and the such, all right? Now, that is officially the end of our lecture time for today, right? Because if you look in the syllabus, we have a 1-hour lecture, okay? The next thing we've got, looking in the syllabus for today, just to show you how the class is going to go, is we have a safety video and a safety lecture. See, that's our lab activity. So this is how things are going to kind of be going. Now, of course, next time we have lab, we're going to have what? Measurements and density. Okay. So, we've got our lecture over with. Tomorrow we should finish chapter 2. And then on Thursday, completely get all the questions and so forth, do measurements and density, and then we'll be ready to start chapter 4 and 5 and all that. All right. Anybody any questions? So what should you be doing? All right. I didn't even bring my textbook. Yeah, I did. I'll let you borrow it. All right. So you should start on problem number 19 on page 43. All right. And you should be able to work with relatively ease to like problem 38 by next time. All right, so here's what you should do. You should work those problems tonight. You do not have to work every single problem because those are paired exercises, right? So number 19 is the same as 20. Number 21 is the same as 22. So work until you feel comfortable. Come in here. I'm going to ask you tomorrow, do you have any questions? Ask me. I will work anything you want. All right? So that will be our quote-unquote office hour. And then, once you get that figured out, we'll move along with more complicated things. All right, are we good? 19 to 38 is kind of where you need to be with the knowledge that you've got now. All right, certainly, by the test, you need to know how to work every problem in the back of every chapter. I mean, that's the ideal scenario. But I'm just kind of giving you cuts off, right, because I've not finished this. I'm not going to take it up. It don't have to be crystal neat. Okay. Some of these guys here are raising their hand and like, man, I've got this. And that's great. They do not need to work every single problem. But some of you guys who've never seen this before, you need to be working more problems than others. It's up to you. You know, this is college. This is not high school. You do whatever you need to do. All right, are we good? Anybody got any questions? All right, wonderful. All right, so I'm done.